Today we're gonna solve a problem based on stack, largest rectangle in histogram. So what we are given an array where each element represents the height of a bar in histogram. Each bar had width 1, and what we have to do, our task is to find maximum rectangular area possible. Supposedly we have heights like 2, 1, 5, 6, 2, 3 in an array, and we have to find the largest rectangle that is formed by the bar 5, 6 with the height of 5 and width of 2. So the answer is 10. So the brute force approach we can do is like for every bar we can expand left and right until a smaller bar appears. Time complexity becomes O of n square. We have to do two iteration in that case for the left and right, which would be too slow. So we need something optimal solution. For that, what we will do for each bar, we need to know the nearest smallest element on the left and nearest smallest element on the right. Because the width of the rectangular depends on how far we can extend. We can use the monotonic increasing stack in in this case. Let's go to the function that we have built largest rectangular area. In this function, if you see, we are creating an empty stack and traversing bars from left to right. We're giving the maximum area, initializing the area as 0 and n as the heights of size. And after that, we're traversing the bars from left to right. And if the current bar is smaller than the stack top, what we are doing, we're just popping the stack and calculating the area using popped bar as a height. Also, width is equal to right index minus left index minus 1 here. And we are also pushing the current index in that, and after a loop we are popping the elements and calculated area and returning the max area to the function. So let's also dry run this case. Suppose if we have heights 2, 1, 5, 6, 2, 3, and our stack currently is empty. If you see, our stack is empty and our maximum area is 0. So what we are doing, suppose if we at the zeroth iteration, our height is 2, our stack is empty, we push 0. Now our stack has 0 at the one iteration, height is 1, we pop 0, area is equal to 2 into 1. So maximum area is currently 2. Now our stack is empty currently and we push 1. Now at the second iteration, if you see, our height is 5 and our stack contains 1, we push 2. Nothing happens. Our maximum area remains same. Then our third iteration, our height becomes 6. We Our stack contains 1 and 2. We push 3. So nothing happens. The area remains same. And then what we will do at the fourth iteration, height becomes 2. That that height becomes 2, and our stack contains 1, 2, and 3. So we pop 3. 6 into 1, that is 6. So maximum height becomes 6. Again, we do 1 and 2, pop 2 from the stack of 1 and 2. So our 5 into 2, our area becomes 10. So maximum area is 10. Then we pop 1, and after that we push 4 and push 4 in that, so nothing change. And then our stack become 1 and 4. So we push 5 at the end, and then our height is 3 at the fifth iteration. So remaining pops doesn't exceed the limit. What we can conclude is that our final answer is 10. That is maximum height of a uh, like maximum height of a largest of a rectangle in a histogram. So let's also dry run this solution. Also, this solution time complexity takes O of n square O of n time, and similarly the space complexity take O of n because we are using the stack. Here we can see the answer is 10.